Good afternoon, everybody. This is Kevin Askew, Senior Sales Manager at Programmer's Paradise. I want to welcome you to our free webinar series, Maximizing Data Quality for Value and ROI. Today's second session will focus on data integration using ERwin design layers. I'm going to start off by giving you a little overview of who we are. Then I'm going to turn things over to Victor Rodriguez, who is our database process modeling consultant, and we'll end it with Q&A after Victor's session. Programmer's Paradise is a leading e-seller of developer and infrastructure tools. We're also an elite CA partner and the #1 data modeling reseller for CA. On staff, we have dedicated CA sales and engineering teams focused on database modeling and infrastructure, providing design and training services focused on being a leader in delivery of CA education. We are also an authorized VET and VSA partner. Under our database worldview, we offer industry-leading tools for your end-to-end database needs, including database platform, design and modeling, development and testing, management and administration, deployment and migration, performance monitoring and tuning, and reporting and mining. I will now turn things over to Victor Rodriguez, who will begin today's webinar.
Thanks, Kevin. So for anybody who may have attended my previous webinar, my initial discussion was regarding how we were going to start mastering our data using the ERwin data modeler. And there were a few examples that I used in there of integrating your data, starting to build the relationships between those models that you have out there, building models and then relating them to each other. And we're actually going to go into much more detail on how we're going to use these design layers to actually build these relationships. I'm sorry, I was actually in the wrong slideshow there. So my name is Victor Rodriguez. I'm the data process and process modeling consultant here at Programmer's Paradise. And many of you may know me from my work at CA. I was actually there for about 10 years before coming here to Programmers. And I bring that knowledge base with me to my position here. And it's kind of these more advanced options that we can see and we're going to demonstrate today. So the agenda for today is we're going to understand what our goals are going to be overall. We're going to look at different data integration options, these common practices that we're going to find across the board with all these different options. And then we're going to actually do 3 demonstrations. One is going to be using the default data warehousing tools that are built into the ERwin software. Then we're also going to use the linked models to build relationships between unrelated models. And then lastly, we're going to look at using the glossary to actually build translations between models to let us share different international models via the mapping of the glossary terms to one central physical model. And lastly, we'll just review some other possible design layer implementations. So what is our goal? The goal now, we hear this more and more, with business and BI becoming a bigger part of our enterprise concerns. We keep thinking, going back to this kind of concept of a single version of the truth. Now, this term has been thrown around for decades now, and it's had different meanings at different times. Oftentimes, for the most part, we find, according to polls, that at least 75%, if not more, different enterprises are either using a current data warehouse or trying to implement some data warehouse in the future. Whether you're using an ERP or looking at MDM or virtualizing your data warehouse, regardless, these are, in the end, we have some common ground that we need to cover. And of course, having metadata allows us to actually start to build these different options, and we're going to look at how we can use design layers to integrate our different systems. So what is the problem that we're encountering? We have many silos of data. We have widespread business processes that are spread out internationally across different groups all over the world, and different groups that have different priorities even within one localization. We also have different corporate cultures that need to be integrated and different taxonomies. Sometimes these are just corporate cultures that arise due to mergers and acquisitions or that occur just internally due to personality differences. And of course, taxonomy is about how these different groups are actually going to start integrating their data when they may have different processes defined within each one of those silos. So how do we start doing that? How do we get our data to communicate with each other? How do we get our people to be able to transparently pass their information, their intelligence back and forth amongst themselves? The goal, of course, this is always this idea of this kind of single version of the truth. We've had very popularly for well over a decade now the concept of a data warehouse. You have your multiple data sources. They're going through some kind of ETL tool and then merging into your data warehouse. Now we have, in recent times, we're looking at virtualized databases. There are pluses and minuses to that. You have speed, but there are dangers that are in using a virtualized database or virtualized data warehouse. But it is a practice that's coming along now. But regardless, even in the terms of virtualization, we do need to consider how are we going to actually document the relationship between our data sources and this landing location. So we're going to look at some common practices that regardless of any kind of implementation that we're going to use, we're looking at defining that data warehouse metadata, and then we're going to look at different techniques for mapping our data sources. So the demonstrations today are going to include mapping the data sources via dimensional modeling options in ERwin. That's going to be the first one we're going to look at. Then we're going to look at linking unrelated models. And lastly, we're going to look at using that translation example that I mentioned before. So let's take a look at ERwin. Okay. And hopefully everybody's seeing my desktop now. And I'm getting confirmation that we are. So we're just looking at a star schema here. And if I go into my customer dimension here, first of all, let me just explain that if you aren't currently doing this, make sure that you have turned on your model properties to allow dimensional and data movement. Most of the features that we're going to demonstrate today will not be available without these options being turned on. This allows you to actually, I'll just give you a quick overview of some of the options we have here. You see that we have calculated the dimensional model roles. You can specify the type of change that is available at the table level. But what we're concerned with here is looking at our column level. And if we go to a data source tab, this is only available if we've enabled dimensional modeling in our model. And we see that, for example, this customer number has already had a data source mapped to it. Now, where is this data source coming from? We've actually defined this data source previously. And we'll see that this tech support operations database DDL is being imported as a data source. And then we can navigate through this menu to select the data source item that we need. How do we create a new one here? So I'm going to use the edit button here. I'm going to create a new. I'm just going to be using the pubs model in SQL Server, so I'm just going to call this pubs. You could specify your system name, host name. In this case, it's going to be SQL Server 2005. This is correct. Now, when I go to the Details tab, I could actually come here and just manually create tables, manually create columns, define data types, comments, etc. Although I can do all this, and I can also import via CSV. The one will point that out as well. But we are actually going to look at importing an actual live database. And in this case, it's going to be the pubs database, which I'm already. And when I click on the Import tab here, I'm actually going to look for that employee table. There it is. I'm going to import that and finish. And now we see here in my pubs, back in the ERwin model, I have my employee table, and I've imported all my columns that are related there. I can actually edit this further. You can actually delete columns you may not want, for example. And once I exit out of here, now I see that I also have a data source for pubs. And the EMP ID is the one that I'm particularly interested in this particular case. Oh, forgot to select it. There we go. And now we actually see that we have multiple data sources defined here linked to this particular column. We could put transform comments in here. Now, this is not programmatic. It's not actually going to generate DDL for you, or if this is a programmatic code that you're generating, it's not going to do that. However, it does give you a central location where you can now define your transform, explain exactly what transform is going to occur on each one of these data sources, link new data sources, and then, of course, report on this. A very important part of this is that now you have a model, you have a central location where you can actually see the relationship between these models and see the actual documented transform differences. Now, for my next example, I want us to take a look at, let me get some of these other ones out of the way. I want to look at an example where potentially you may be looking to link a physical model, for example, to multiple application models. So in this particular case, you may actually have a live physical implementation, and you need to have your application developers actually have access to the data within there to see the relationship between the application they're developing and the back end, the server they're actually going to be using. Another possible usage of this would be to actually integrate multiple systems into one. You want to build a mapping relationship between like a SQL Server and an Oracle database to a landing site where that data might be being transformed. So the question arises is, how do we build a relationship between the objects that exist in these different models to document where they are, what's going on those different environments, and then actually create that linkage, and as we're creating the linkage, to actually have that so we can use that as a reference point, so we can see later on without having to rely on an email that we received or a spreadsheet or something like that. How do we have a graphical representation of that relationship? So in this particular case, I'm actually going to take this model and I'm going to use the tools, link model source, and I'm going to select this app1 v1 model as my source model. And now what we're seeing in this particular case is that, let me actually minimize this and just go to the table level to keep this as simple as possible. We have an employee table in my app model, and then we have a generic person table in my physical implementation. Now what I do is I use this match two items tool, which is available right here in the upper left. And I highlight one, then the other. Do you want to match these? We say yes. And now at the column level, we can start aligning these objects as well. And of course, like we're used to seeing, we see the misalignment. For example, physical name is showing as a difference, etc. The key takeaway here, though, is that we've now built this, and we only need to build it once. So once I've actually linked these and I finish, I'm actually going to find that I now have a model source. This app1 model is my model source. And the advantage here is that at any time, I simply, now we're not using the complete compare. This is a very important point. Oftentimes people will link models or they have derived models. And once they've derived the models, they actually try to do a complete compare between them. But you're missing out on the advantage that the linking actually allows. We want to do tools, sync with model source, and we'll see that here's our app1 model. And when I click on the sync button, we'll see that my tables and my columns are already aligned. So now if my developer has made a difference, we'll see that the data types are actually in sync here. But if they were out of sync, we could see it here. We could generate a report by clicking this one button. It could generate it as HTML or different Excel, for example, is another possible reporting option, and make that available to the rest of the team. Or we can actually make live changes. If we actually are going to force this name change, we can make it here. If we're going to force a data type change, etc. Now, we can link more than one model. So I want to link this. This may be an HR application, for example, and my client is a person as well. It's also related to the employee table. Perhaps my employee is actually my client in this table. So let's link a second model. Once again, I go to Tools, Link Model Source. I'm going to select this apps2 model. I'm just going to click Finish. And once again, we're going to do a manual alignment. This is just a one-time procedure. If you accidentally align objects you don't want to align, you can unalign them at any time. There's an unalign, unmatched to items option as well. And that's it. We are done now. And we can actually see, for example, in this particular case, that the differences here below. So similarly now, we click Finish. And we'll see that we now have two data sources. We can actually navigate to those data sources via these links. This particular model is in the Model Manager, but you can do this with standalone models. You can actually just navigate to them. And we can even use naming mapping files, and that's actually what we're going to discuss in the next option, or in the next sample, I should say. So now when I want to do a sync in the future, you actually see that we have both models here available. So now we quickly see which models are linked, and we can just select them right here from the menu, click the sync option. We see that everything's already aligned. As our models build and the complexity grows, this becomes more easy to navigate. What's aligned is shown, what's not aligned is shown as well. And then we can import, export changes, use this for reporting purposes, etc. And I'm actually going to close these out to clean up my desktop a little bit. And now the last sample I want to show everybody before we get back to the presentation is going to be a little more complex. Now we're going to use linking models, and we're going to use the glossary option. So what happens when we have a project that, for example, may span multiple languages? So here's an example where we actually have a logical design in English. We have this employee table. And we also have Spanish design as well. And we see that the different attributes are defined here using Spanish names. So in this particular project, there's many different ways you can tackle this, but in this method that we're going to discuss today, what we came up with was these two groups met. They discussed what was the taxonomy, the terminology that they were using internally. They broke these down into very specific glossary of terms, very explicit definitions for their different classes and their different object types. And once they had this rigid definition of all these different names, they standardized their models to match those names. And once they had these standard terms, they were actually able to build a glossary, which I'm going to open here now. And what we see here is we see the English names here, the long logical names, mapping to physical abbreviations, etc. So we're creating these terms for both models. And now we're going to look at the Spanish model. Oh. And once again here, we see that we're working off the same physical terms, and we're now translating those using Spanish. Now, when this actually was implemented, and we actually did implement this in one particular scenario, what ended up happening was that for the most part, we actually came up with that taxonomy of terms. We just started using very basic translation, using just a translator or someone who speaks the language, and very quickly start to map these physical names to these glossary terms. In the end, you need to do further reconciliation. It's possible that, if someone is using last name or you may be using surname instead of last name, and there are a Spanish word for surname, so then the decision has to be made. Are we going to use that English taxonomy as well in both cases, or are we going to change it to last name and make that a standard? So these are issues that need to be ironed out before we come to a final decision. But the building of the glossary is going to reveal these limitations and reveal what needs to be changed as far as these naming standards. But the nice thing about building this, that once we've had this standardization built, these names that we're going to be implementing in both designs, is that it adds us, it allows us to now translate our models, and it gives us a one-step process of integrating them. So in this particular case, I've already synchronized both models. Or I should say I've already linked both models, I should say. But I can actually remove, I actually wanted to add that model later, so let me do that after the fact. So the first step is we've already have our English model attached. And what we're going to add via versus the previous step is that we're going to now use our naming standards file, which we've specified here. And I'm actually going to do this from scratch with the Spanish sample model. So we're going to step through this editor again in just a moment. If I do a sync, I see that everything's now is synced up. Now what we see here, since we're using that glossary file, is that we are not confused as to what aligns with what. Since we're using the glossary file, everything has already lined up. These names are aligned, and we see that they're mapping correctly between our gold standard physical model and our logical English model. So let's add the Spanish model as well. Let's see what happens. I'm going to select the open logical only Spanish model. And the first thing we'll notice, which is very nice, since we're using the glossary file, we'll notice that the employee table has already aligned with the employee table. And if we go to the column level, we'll notice that many of the items are already aligned. Now, this is all being handled due to the attached glossary file. However, what we find here is that this employee ID column is missing. So the first thing we should do, I'm actually going to step out of here. We're not going to do anything other than the link. And in my model properties, actually I want to go to my model sources. And we'll see that both in this editor, the model sources properties editor, we have both models available. What I have here for my model 3, which is actually my English language model, is an attached naming standard file. So let's do the same thing for my Spanish model. I'm going to use a file. I've already created my glossary. So I'm going to use that one. And now once again, let's do a sync with model source. Oh, I synced to the wrong model. Sync with model source, Spanish model, sync. So what we see here is that the employee ID column is missing. So let's export it to my Spanish model. Issues resolved. I'm going to click Finish. And now let's take a look at the Spanish model itself. Employee ID has imported as empleado identificado. So this has already done the translation for us. So in one step, we've actually allowed us to report on the relationships between these objects. They've automatically been synchronized due to the fact that we attached the glossary file, which did the translation for us, which aligned the objects. And not only that, but now exporting the objects between the models will automatically translate them. So if you've added a new column, if the decision is made to import the office location from the Spanish model into our core physical model, and then we need to synchronize that with the English model. We will see that the names that are going to be generated on the export are going to be office location, which saves us the step of having to do the translation. Now, I've seen this also implemented in, for example, in a Korean model to English translation. Now, this is much more complex in the fact that oftentimes that characters in Korean actually represent phrases, actually represent concepts. But once again, those concepts need to be mapped to the English language or any kind of translation. So if you do that ahead of time, it actually saves you a lot of trouble. Now, this may seem like a lot of overhead for a large project, but when you think about the fact that you may be years into a merger before you realize that your business information is not aligning between your two systems. So if you actually iron that out ahead of time, you save yourself a lot of time in the long run. And that really is the core principle of what's really great about using a data modeler, defining your metadata. And anybody who models regularly is already aware of the fact of how important having those definitions are. Now, quickly, let me see if I could jump back to my presentation here. Okay. So now I want to discuss very quickly, using some of the concepts we just illustrated there, some further implementations for this kind of design. So where else could you use some of these concepts? Oftentimes you may find you have many logical designs. You could have maybe different applications that are already designed or already in the works, and you do not know what is going to be my physical implementation of all these different applications. Rather than building the physical design and the applications separate from each other, then why not actually use the application data, if that's where the end you're starting from, to build your physical model. You'll see where your data is overlapping, where it's not. Start to build a physical model from there. If you have conflicting column names, if you have conflicting data types, you'll actually know it as you're building the physical model. You actually know it before you get to the database design level. And you're doing that because you're actually mapping your physical model based on your actual input, which is a great way to prevent bad data quality in the future by having bad integration. And of course, once you actually get to the point where you've decided on how this physically is going to be implemented, so your physical model is actually designed, these arrows are actually moving in both directions. So these are bidirectional in the fact that now we change our a data type, we make a value nullable or not, we have explicit definition, our department identification code goes from being a 4-digit number to a 5-digit number. All this is bidirectionally available via the linking of these two models to each other. So we have this constant conversation in both directions between our application models and our physical models. So this can happen when, for example, you're integrating multiple applications, as I mentioned, or it could also be that you're integrating, non-standardized, non-RDMS models like XML models, which you can import via the meta-integration modeling bridge in ERwin. So you may be integrating these different types of information. You may have data that's coming from Excel spreadsheets or things like that, and how do you start to build a relational model from that? Another implementation of this is you may actually have multiple physical databases, and you may be virtualizing your data warehouse. So let's say you have a virtualized data warehouse. How do I have my definitions? I see what my virtualized data warehouse is. I see where the tables are going to land, but how do I know what the relationship is between that and all these different silos of data? If we create different models and then we link them back to that central physical design, we'll get a much better idea of how these relate to each other. Another possible implementation is, and this is very common, I think many people are actually pretty familiar with this, is using a logical data model to derive multiple physical designs. And I do quickly want to jump back to my ERwin. And I do want to just introduce some of the options that are available here. We're not actually going to do these, but I do want to make sure that everybody's familiar with the different terminology here of the actual design layer options. We can add a model source. Adding a model source will actually take an existing model. It'll allow you to add you can add the entire model, or we can do what we did before, where we're actually specifically selecting columns and tables to import. But you can add the entire model. If objects already exist in your model that align with those other objects, they will merge during the add model source. So if you have two tables with the exact same names, they're going to merge, columns with the same names, domains, etc. However, if you have objects that do not align, if you have domains that have columns that have different data types, for example, you are going to see redundancies in the design, so it's not the best way to go about it. In that particular case, I actually think you should use the link model source, since you can do the manual alignment, and that will give you much better results. So you have the add model source option. So this is something that we actually frequently have requests for. You want to build one giant enterprise model, and we're actually going to discuss this in one of the later slides, but you want to build one large enterprise model from many, many different database models. How do you do that? You take a blank model, and you just start adding each one of those models as a model source, and you're going to start seeing it populate with all the objects that exist in those models. And then you can synchronize them, just like we saw before with the internationalized model sample. We could synchronize them bidirectionally. Linking models. This is what we actually saw before. You're linking the model. This basically allows you to do an add, but it gives you much more granularity. You can specify exactly what objects are going to link with other objects, etc. Syncing with model source is what we've also seen previously, where we're actually going to, it's going to allow us to do a synchronization. After building these relationships, we can sync. Do not use the complete compare. You use the sync with model source if you're syncing between a child and parent model relationship. Deriving a new model, and this is the topic that I'm currently discussing, which is the concept of taking, for example, there's many ways you can do a derive, and any model type to any other model type is supported. But let's say we have a single logical implementation, we've designed it, we need to now derive a physical model for Oracle, for an Oracle design. We use derive new model, and we derive it, we specify during the derive process a physical or logical physical model, and we simply specify what our target database is going to be. Everything else is going to be standard migrated using the ERwin standards, but you can specify a naming standards file. You can specify a data type standard file if you've already customized the names you use for Oracle or the data types that you prefer, rather than the generic ERwin ones. You can also do this after the fact, but it's up to you. So as we see here, when I go to define a new physical or derive a new physical model, I have all of these models are available. So I can actually take that logical model, derive a Oracle model. I can take that same logical model as a source, derive a Progress or ODBC or a MySQL. Any type of supported database can be derived from that source logical model. You can also take a physical model and then derive another physical model, although that's not as common as taking a central logical model and then deriving different physical designs from that. You can also, of course, use a migration process. Let's say that you're actually migrating your data from a SQL Server database to an Oracle database. You can take your SQL Server model. If you've already reverse engineered it, you use the tools, derive new model. You derive your Oracle model. This is going to bring all your metadata, all your table definitions. Everything's going to come automatically. You build that, and now you need to actually worry about migrating the data. There are tools out there. ERwin's not going to migrate your data for you. We're only going to handle the metadata. But there are tools out there that allow you to map your SQL Server to Oracle and vice versa, or any other common vendor databases. And I think that's all I wanted to cover here within the menu items. Let me go back to our presentation. So, logical data model used to derive multiple physical implementations, bidirectional once again. If you make changes to your Oracle design later on and you decide that these are properties that need to exist in my logical model, they can be pushed back into the logical model. What's nice about splitting these objects apart is that allows you to, for example, you may very well have to create physical objects that you do not have to want to enforce in the logical design. These physical implementations do not map to any logical concept. And by not using a classic ERwin logical physical model, by deriving physical-only models or even combined models if you want to go that route. It allows you to actually do that. It allows you to have the objects that you want synchronized without having to worry about marking objects as logical only or creating a relationship line and coloring it white or something in the background so you can't see it on the background. These are things that you can actually do by just simply by deriving the model and filtering out the objects that are unnecessary as part of your subordinate design. Next possible usage is to actually use a large model breakdown. Oftentimes you may very well find that you have models that have grown so large and represent such a huge part of the enterprise that even though you do want to have some representation of the entire enterprise, that you still need to have some more granularity, that nobody's ever going to want to look at all 10,000 tables at once. So you may want to break that down. I mean, you already can break down into subject areas within the ERwin software itself. And of course, you can derive models based exclusively on those subject areas. So once you derive based only on those subject areas, you've already started to build this view of your model. And by building that limited view of the model, you're including only what's important to that particular level of the enterprise. And then, of course, bidirectionally, you can import those changes back into your model. You can report changes from that gold standard model back into your subordinate models. But, of course, having much smaller models actually allows you to have more flexibility, more speed, or less downtime in migrating a huge model or saving it to your model manager repository or merging changes that may not even matter to your particular level of design. And that's a very key point. So this is basically the opposite of what I was describing initially, where you can actually take multiple smaller models and merge them into one large model. This is a method of going the other direction, where you can take a huge model and you may want to break it up based on schema owner, et cetera, or just application levels, depending on who's doing what within the enterprise. So, I guess my concluding slide is missing here. So in conclusion, I just wanted to, we can just reiterate the fact that, I wanted to introduce the concept of how we're actually going to use our data modeling chops, what we already are strong at, what we already have, software that we already have in-house, teams that are already knowledgeable in these fields. How do we maximize our investment? How do we start to implement that data quality, that next step, the BI that we need to get our hands around, the MDM or data warehousing solution? How are we going to leverage what we already know to help us in the next step? And using some of these techniques, using the design layers to build these relationships between our models gets us halfway there. So we actually start to, once we know where that data is coming from, where we know what the landing pad is going to be and where all those different data sources are, we can actually start to build those relationships and see how they map to one another, report on them, make that publicly available, and catch issues before they arise. And by doing some of these things, a little forethought will save us a lot of money and a lot of time in the end. And you can start this very small, start it in a very localized area. Just start it with your, the local groups, with your, whoever you're working with currently. And you can see a very quick return on investment, not only in money, but in time that's being saved by getting the project right the first time. And once you have that success, you build on it, you can spread it out, and it can grow across the entire enterprise. So that's pretty much all I had for you today. I did want to mention my blog, which is maximumdatamodeling.blogspot.com. My Twitter feed is Max Data Modeling, if anybody's on Twitter. And there is a Maximum Data Modeling group on LinkedIn. You can either reach me on my LinkedIn contact, or you can simply look for Maximum Data Modeling, and that'll get you there as well. And lastly, I do want to quickly mention that if you're not currently using ERwin.com, the website, there's a lot of really useful information there relating to just general or data modeling topics, some great white papers and stuff. It's not all just ERwin-centric. There's a lot of good just general concepts. There's a lot of leaders in the field that are posting there regularly, and a lot of them are actually presenting this month. There's still a week left of ERworld, which I'm actually competing with right now, unfortunately, given the we had this time in place well before we knew about ERworld, unfortunately, so it's probably why our attendance is relatively low today. But this video will be available later, so we will make that available to everybody. I do want to mention, do go to ERworld. I'll be participating there. I'll be tweeting. And there's some great topics coming up. If you've missed any of the ones I presented there earlier this month, if you missed any of the earlier topics, do make sure you subscribe and get those replays later on. And there's ERwin is R8 is going into open beta beginning October 1st. You do not have to be an ERwin user to jump in on board on that, and I actually would love to see everybody participating, because the more people participate, the better the tool is going to be in the long run. So that's pretty much all I have to promote right now. So thanks, everybody, for your time.
At this time, we'd like to open it up to any questions that you may have for Victor. In the meantime, feel free to email any questions that you may have after the webinar to Victor at ca.erwin@programmers.com. You could also visit us on the website at www.programmers.com/ca. And to register for any webinars or to view any webinars on demand, www.programmers.com/ca. And we're looking forward to the third session in our series, which will take place on October 21st. The topic of that one will be collaborate with business stakeholders using C8 ERwin templates. Seeing no questions, we'd like to thank everybody for attending, and have a great rest of your day. Thank you.